Yes, hello. Good evening. Good evening. Good evening. Good evening to all of you. Everyone, please confirm, beta. Am I audible? Am I visible clearly to all of you? Everyone, please confirm. Am I audible? Am I visible clearly to all of you? Audio video is clear to everyone. Please confirm in the chat box. So, good evening, Dadan. Good evening, Umar. Good evening. Good evening. Audio video clear. Very good. How are you all? How are you all? How are you all? So, I hope you all are good and preparing well for our exam. So, we have successfully completed our 2 chapters. So, we have completed our 2 chapters. Chapter 1 was Fundamental of Surveying. We have completed the discussion for Fundamental of Surveying, and just we have completed in the last class discussion related to the linear measurement. And now we are going to start our 3rd chapter, and that is also very important chapter from where you can expect the question in your GATE exam or in other exam. That is going to be the chapter number 3, compass surveying. So as we know in the case of surveying, in this subject we have to measure basically 2 things. One is distance and another is angle, that we have discussed. So we need to measure the horizontal distance, we need to measure the vertical distance. Similarly, we need to measure the horizontal angle and we need to measure the vertical angle. With the help of these measurements, we can define the relative position of a point, and with the help of that relative position, we can prepare the plan or map. So in the case of linear measurement, we have used the chain or tape. So with the help of the chain or tape, we can measure the horizontal distance. As of now, we have not discussed anything related to the measurement of the vertical distances. Yes or no? In the case of chain surveying, in the case of tape surveying, whatever measurements we have performed, all the measurements were related to the horizontal distances only. Similarly, now we are heading towards the angular measurement, and with the help of the compass, which angle we can measure? Yes, first of all, the compass is going to be used. The compass we will use for measuring the angles. But can we measure all the angles? Can we measure both horizontal and vertical angles with the help of the compass? This is the first question. The answer is going to be no. With the help of the compass, we can only measure the horizontal angle. So, as of now, we will talk about the horizontal angle only. There will be no discussion related to the vertical angle. I hope this point is clear to everyone. So with the help of the compass, with the help of the compass, with the help of the compass, we can measure the horizontal angle. We can measure the horizontal angle. And I hope you all are aware what do you mean by the horizontal angle that we have discussed. If all the points are lying on the same plane, so the angle between those lines you can say is going to be the horizontal angle. This was the condition. So if all the points are lying on the same plane, all the lines are lying on the same plane. So for example, this is your plane and this is your line AB. This is your line AB and this is your line AC. So this is your line AB and AC. So this theta is going to be the horizontal angle that we have also discussed. Yes. Yes, not plan, in plane. So in the case of compass surveying, in this lecture, we will cover the introductory part. We will see how we can measure the angle with the help of the compass. What are the various terminology like bearings, designation of the bearings and the magnetic declination and the dip. So these are the topics that we will cover. So let's start the discussion. So first of all, what is the basic principle of compass surveying? What is the basic principle of compass surveying that we are going to discuss? So in your 11th or 12th class, you must have seen the magnetic needle. Have you seen the magnetic needle in your have you seen the magnetic needle in your school days? Yes, you must have seen. So if we take the magnetic needle, if we take the magnetic needle and let's say we have disturbed that magnetic needle, but after some time when this needle is going to be stable, it must be indicating some direction. Yes or no? When the needle will get stable, it will indicate some direction. Yes or no? I hope you all are aware which direction this needle will indicate. So it will indicate the north and south. It will indicate the north and south. Yes or no? More precisely, we can say if we are using the magnetic needle, it will indicate the magnetic north and magnetic south. It will indicate the magnetic north and magnetic south. So there are two north and there are two south. There are two north and there are two south. How? Let's see. So as we know, this is the earth. This is our earth. Yes or no? If we are considering this our earth, so this is going to be the north pole and this is going to be the south pole. This is going to be the north pole and this is going to be the south pole. But as we know, our earth is tilted at its own axis. This perfect shape is not there. This perfect position is not there. Our earth is tilted at its own axis. And that tilt angle is 23.5 minute. That tilt angle is 23.5 minute, so that we are seeing this position of our earth. We are seeing this position of earth. That's why we are getting the north and south. One more north and one more south. Due to this tilt angle, we are getting the one more north and one more south, and that north, that south we are considering as the magnetic north and magnetic south. That north and that south we are considering as the magnetic north and magnetic south. Magnetic north and magnetic south. So I hope you all are aware. That if we are using the magnetic needle or magnetic compass, so with the help of the magnetic needle or magnetic compass, which north or which south we can locate? Which north and which south we can locate with the help of the magnetic needle or magnetic compass? So to differentiate this, for this we are using the true north. For this we are using the true north and true south, and due to the tilt, the actual position is there. For that we are using the term magnetic north and magnetic south. Yes. So with the help of the magnetic compass, we can locate the position of magnetic north and magnetic south. Magnetic north and magnetic south. We can locate the magnetic north or magnetic south with the help of the magnetic needle or the magnetic compass. I hope discussion till now is clear to everyone. Yes or no? Any doubt to anyone till now? Okay, so now let's move further. So here we are talking about the angles measurement. So what is the objective of the compass surveying? So with the help of the compass surveying, we can measure the horizontal angles. We are not going to measure the vertical angles, because here we are using the compass. So there will be some issue with the accuracy. There will be some issue with the accuracy, because if there will be any object, if there will be any object that is having the magnetic characteristics, so it will disturb the magnetic needle or magnetic compass, and that to due to that disturbance, there will be error in our measurement. Yes or no? If there will be any object that is having the magnetic characteristics and that object is nearby to the compass or the magnetic needle will be disturbed due to that object, and because of this there will be error in our measurement. So there is some accuracy issue with the compass surveying. So limited use will be there. But as of now, what we have discussed, on that basis we can conclude the main objective of the compass surveying is the measurement of the horizontal angle. Yes. Okay, so now let's move further. So if I talk about, let's say, so these are the instruments that we are going to use. There are the two types of the compass. One is going to be the prismatic compass and another is going to be the surveyor compass. One is going to be the prismatic compass, another is going to be the surveyor compass. So practically in the field we are using the prismatic compass more frequently as compared to the surveyor compass. So let's see some basic construction detail of the prismatic compass and surveyor compass. So this is the compass. There is a metallic box, as you can see, black color box. In the upper part there will be a glass plate, and in the inner side of this box you can see there is a graduated ring. There will be a ring something like this. There will be a graduated ring something like this, and this ring will held over a pivot point. This ring will held over a pivot point something like this. So if you go for the graduations, so here the graduations are marked. Here the graduations are marked. With the help of these graduations you are going to define the horizontal angle that we will see. In the case of prismatic compass, these graduations are marked and that graduations are going to be inverted. So for example, in general we are writing 5 like this, but when you will see the prismatic compass, the graduation will something like this. 5 will be written like this. 5 will be written like this, inverted shape. The graduations are, the markings are grouped inverted in the case of prismatic compass. So if you go for further construction detail, so there will be two sides are there. This portion we are considering as the I side and this portion we are considering as the objective side. I side will be there and objective side will be there. On the I side you will see here there will be a small opening. So when you will see with the help of this opening, the ring is at the below position. You are seeing in this direction, but the graduated rings in this position. Again, so somewhere here we have placed a prism. Here we have placed a prism. So with the help of prism, when I will see in like this, I will able to see in the bottom portion. In this way we can read the graduations. So in the eyepiece there is a prism provided. With the help of the prism we are going to see the observation, we are going to see the readings, and that's why we have marked the inverted grouped readings on the prismatic compass. In the objective side there will be a slit opening. Slit opening, as you can see, a wire will be there. With the help of this wire we can do the proper sighting. With the help of the objective side we can do the proper sighting that we will discuss. In the case of surveyor compass, this ring can move. This ring can move. In the case of surveyor compass, these are the graduations and these are fixed. These graduations are fixed and there will be a magnetic needle which can be movable. Magnetic needle can be movable. Similarly, I side will be there, objective side will be there. So here the graduations or the marking are marked in the normal position. There will be no inverted marking. So I hope now you are aware with some basic construction detail of the prismatic compass and surveyor compass. More frequently we are using the prismatic compass in the field for the measurement of the angles. Point is clear to everyone? The discussion till now is clear to everyone, yes or no? Please confirm in the chat box and please be interactive in the class. So, there is some comparison between the prismatic compass and surveyor compass. But let's come back to the main point. What is the why do we need objective in prismatic compass? That we will talk later, don't worry. That we will talk later. As of now, I have discussed what are the various components, what are the various parts of the prismatic compass, and what is the use of those parts, that we will discuss in the coming discussion. Don't worry. Don't worry. So, I'm asking a simple question. Let's say this is the line AB. Define the horizontal angle of this line AB. Define what will be the horizontal angle of this line AB. Can you please tell me what is going to be the horizontal angle of this line AB? What will be the horizontal angle of this line AB? Can you tell? What will be the horizontal angle of this line AB? What will be the horizontal angle of this line AB? We cannot tell. Obviously, we cannot tell. Why? Because without reference, we cannot define the angle. Without reference, we cannot define the angle. Yes or no? That is your point? Yes, without reference, we cannot define the angle. There must be a reference line. So let's say, now I am saying, let's say consider this line as a reference line. Now let's say consider this line as a reference line. So as we know the reference, now we can define this horizontal angle, and let's say this theta is going to be the horizontal angle. साइन थीटा, साइन कहां से आ गया? If we know the reference, now from that reference we can measure this angle. Why you are taking the normal? Why you are taking the normal? We are not taking any component. No matter it will be less than 90 or it will be less than greater than 90, no issue. The point is simple. All these lines are lying on the same plane. Pooja, make it clear. The reference line and the line AB are in same plane. The reference line and the line AB, both line are lying on a same plane. Then only we can say this theta is going to be the horizontal angle. So from the reference we have measured simply this angle theta, and this theta will be considered as the horizontal angle. This theta will consider as the horizontal angle, yes or no? This theta will consider as the horizontal angle, yes or no? So in the compass surveying, actually we are measuring the horizontal angle in the terms of bearing. In the case of compass surveying, what is the terminology? In the case of compass surveying, for reference we will use the term. For reference we will use the term meridian. For reference we will use the term meridian, and for angle, for horizontal angle, we will use the term bearing. So with the help of the compass, we are measuring the bearing. And by default, because the angle that we are measuring with the help of compass, that is the horizontal angle. So bearing is the horizontal angle. So we are measuring the horizontal angle in the form of bearing in the case of compass surveying. Can I say like this? Can I say like this? So there are two types of the references. There are two types of the references, or you can say there are two types of the meridian. So one is going to be your true meridian. One is going to be your true meridian and another is going to be your magnetic meridian. One is going to be your true meridian and another is going to be your magnetic meridian. That we will discuss. Don't worry. That we will discuss. What is the true meridian? What is the magnetic meridian? As of now, we know our reference line. For that, we will use the term meridian, and there will be two types of the meridian. One is going to be the true meridian and another is going to be the magnetic meridian. Similarly, we can define the two types of the bearing also. Similarly, we can define the two types of the bearing also. One is going to be the true bearing. One is going to be the true bearing and another is going to be the magnetic bearing. Another is going to be the magnetic bearing. True meridian is retailed to geographical north and south. आ रहे हैं. We are coming on it. We are coming on that discussion. Don't worry. Why you people are in too much hurry? In hurry. So there is always a learning process. For example, when we were child, when we were small, so we didn't started running first. Yes or no? But step by step. Learning will be the step by step. First, I have introduced the term, then I will explain. So please follow that process. Please follow that process. Okay. So just I have discussed what is the true north. Just I have discussed what is the magnetic north. No issue, no issue. All the points will be answered. All the concepts you will get. This is for sure. No matter you are covering this chapter first time or third time. No issue with that. But listen carefully. But concentrate on the discussion. You will get all the concept. So, as of now, we have discussed in the case of compass surveying, our objective is to measure the bearing. For bearing, for angle measurement, we require reference, and that reference we will consider as the meridian. That reference we can consider as the meridian. That reference we can consider as the meridian. So now there are two types of the meridian. One is going to be the true meridian. Another is going to be the magnetic meridian. Similarly, there are two types of the bearing. One is going to be the true bearing. Another is going to be the magnetic bearing. So now, what is this meridian? Let's talk about this. So what do you mean by the true meridian? What do you mean by the true meridian? The line joining the true north and the true south pole of the earth along the curvature is called the true meridian. Just we have discussed, if there were no tilt, if earth is not tilted at its own axis, at that time, at that condition, whatever north and whatever south we will get, that we will consider as the true north and true south. So a imaginary line which joining the true north and true south, a imaginary line which is connecting the true north and true south will be considered as the true meridian along the curvature of earth. Along the curvature of earth is called the true meridian. Similarly, if I talk about the magnetic meridian, can I say a line connecting a line joining the magnetic north and magnetic south is known as the magnetic meridian. A line connecting the magnetic north and the magnetic south of pole will be considered as the magnetic meridian. Can we say like this? So if I want to represent the true meridian and magnetic meridian in a single diagram, how can I represent? So for example, let's say this is your earth. Let's say this is your earth. So can I represent the true meridian something like this? Can I represent? Can I represent the true meridian something like this? Can I represent the true meridian something like this? The line joining the true north and true south pole is known as the true meridian. Similarly, can I represent the magnetic meridian in this diagram also? Yes. So let's say this is your position of the magnetic meridian. A line joining the magnetic north, a line joining the magnetic north and magnetic south. This is going to be your magnetic meridian. So now I think this term is clear to everyone. What do you mean by the true meridian and what do you mean by the magnetic meridian? What do you mean by the true meridian and what do you mean by the magnetic meridian? This point is clear to everyone. Line joining the true north and true south is known as the true meridian. Line joining the magnetic north and magnetic south is known as the magnetic meridian. With the help of the compass, we can locate the magnetic meridian. With the help of the compass, we can locate the magnetic meridian. Yes or no? Because with the help of the compass, we can locate the magnetic north and magnetic south. So we can identify the magnetic meridian with the help of the compass. We all are living on the surface of the earth. Yes or no? We all are living on the surface of the earth. So just try to visualize at any place. Can I locate the position of the magnetic meridian with the help of the compass? At any place. For example, this is the place. Here I will use the compass, and with the help of the compass I can locate the magnetic meridian. Yes or no? So let's say there is any line. Let's say this is the line OA. How many angle we can measure for this line OA? So we can measure two angles for this line OA. We can define two angles for this line OA. One angle we can measure from the magnetic meridian and one angle we can measure from the true meridian. Yes or no? One angle we can measure from the magnetic meridian and one angle we can define from the true meridian. The angle that you are measuring with respect to the magnetic meridian is known as the magnetic bearing. Is known as the magnetic bearing of the line OA. The angle you are measuring with reference to the true meridian is known as the true bearing of the line OA. Is known as the true bearing of the line OA. So now I think you are clear with the four terms. So what do you mean by the meridian? This point is clear to everyone. Meridian is going to be the reference in the case of compass survey. What do you mean by the bearing? Bearing is going to be the horizontal angle in the case of compass survey. There are two types of the meridian. One is going to be the true meridian. Another will be magnetic meridian. Line joining the true north and true south pole is considered as the true meridian. Line joining the magnetic north and magnetic south will be considered as the magnetic meridian. So if we are measuring the bearing of any line and we are considering the reference at the true meridian, so we will get the true bearing. Yes or no? If we are measuring the angle of any line and we are considering the reference as the magnetic meridian, in that case we will get the magnetic bearing of that line. I hope the point is clear to everyone. All these terms are clear to everyone, yes or no? So as of now, whatever we have discussed till now, if anyone having any doubt, any query at any point, you can ask your doubt, you can ask your query. Whatever we have discussed till now in the case of compass survey, if at any point you are having any difficulty, any problem, any query, you can ask your doubt, you can ask your query. True bearing is the horizontal angle True bearing is the horizontal angle that we are measuring with reference to true meridian. For measuring the true bearing, we are considering the reference as the true meridian. For measuring the magnetic bearing, we are taking the reference as the magnetic meridian. Bearings means horizontal angle. We are differentiating this bearing based on the reference. If we are considering the true meridian as a reference, we will get the geographical north and true north are same, no. Magnetic north and magnetic south, the exact position, those are the exact position that we can consider as the geographical north and geographical south, actual position, by considering the tilt. By considering the tilt. So, both bearings are the horizontal angle, but if we are considering the reference as the true meridian, we are getting the true bearing. If we are considering the reference as the magnetic meridian, we are getting the magnetic bearing for the same line. As you can see, this, let's say this is theta, and let's say this green one is alpha. So, theta is going to be the magnetic bearing of line OA, and alpha will be the true bearing of line OA. Theta is going to be the magnetic bearing of line OA, and alpha will be true bearing of the line OA. Dadan, now your doubt is clear? Dadan, now your doubt is clear? How we are defining the true bearing, how we are defining the magnetic bearing, how we are defining the true meridian, how we are defining the magnetic meridian. Now I think this point is clear to everyone. Now can we move further? Can we move further? Okay. So, bearings horizontal angle measured for a line with reference to the fixed meridian is known as the bearing. If this reference is going to be the true meridian, we will get the true bearing. If the reference is going to be the magnetic meridian, we will get the magnetic bearing. Can you please tell me, with the help of the compass, which bearing we can measure? For any line, which bearing we can measure? With the help of the compass, which bearing we can measure? True bearing or the magnetic bearing? True bearing or the magnetic bearing? Obviously, the answer is going to be the magnetic bearing. Bilkul, absolutely correct. Okay. So now we are going to see what are the various way to represent this bearing. Let's say, for example, we know the distance. How we can represent the distance? How we can represent the distance? What are the various units? With the help of those units, we can represent the distance. For representing the distance, we can consider the unit as mm, we can consider the unit as centimeter, we can consider the unit as meter, we can consider the unit as kilometer. Yes or no? All these are the units that we can use for representing the distance. Inch, foot, yes. There are various units that we can use for representing the distance. Similarly, just we have discussed about the bearings. So there are two ways, there are two methods that we are using for the representation of the bearing. Like, one is going to be the first is going to be the whole circle bearing system. In short, we can say WCB system. And another is your quadrantal bearing system, or you can say reduced bearing system, So another is QB or RB system. So one is your WCB system and another is your QB or RB system. For example, let's say this is the point A and this is the point B. Whatever units we are considering, no matter, but the actual distance will not change, na? So for example, the distance between the point A and B is 1 kilometer. So same we can represent as 1000 meter. Yes or no? But the distance will remain same. Representation is changing, but the distance will not. What is the meaning of 1 kilometer is having the same meaning of 1000 meter? Yes or no? We have represented the same distance in different units. Representation is changing, but the actual meaning, the actual distance will remain same. In the same way, for the representation of the bearing, we are going to discuss about the two methods, two systems, but the bearing will remain same. Only the representation will change. The bearing will remain same, only the representation will change. So now let's understand how we can represent the bearing in the WCB system and how we can represent the bearing of any line in the case of RB or QB system. So let's see the discussion. So in the case of WCB system, so let's say this is your east, this is your west, this is your north, and this is your south. Listen carefully. This is your east direction, west direction, north direction, south direction. Let's take multiple line, no problem. So for example, this is the point O. This is the line OA. This is the line OB. This is the line OC. This is the line OD. These are the four lines for which I have to represent the bearing. So let's see the characteristics of the WCB system. Let's see the specification of the WCB system. In the case of WCB system, we will measure the bearing, we will measure the angle. So for the measurement of angle, we required a reference. Without reference, we cannot take the measurement, na? Without reference, we cannot take the horizontal angle measurement. So the first and foremost thing that is required, that is the reference. So whenever we will represent the bearing of any line in the WCB system, always we will consider north as a reference. Always we will consider north as a reference. So if we are considering this north as a reference, now we have again one question. Sir, this angle we should measure in the clockwise direction, or the angle we should measure in the anti-clockwise direction? Yes or no? We can measure the angle from the north in the clockwise direction, or we can also measure the angle from the north in the anti-clockwise direction. So what will be the direction? So if you are considering the bearing, you are representing the bearing of any line in the WCB system, always we will measure the angle in the clockwise direction. Always we will measure the angle in the clockwise direction. Always we will measure the angle in the clockwise direction. So let's say, for example, if you want to define the bearing of the line OA, you want to define the bearing of the line OB, you want to define the bearing of the line OB, OC and OD in WCB system. So how you can represent the bearing? Let's see. So for the line OA, if we want to measure the angle, we will measure the angle from the north in the clockwise direction. Can I say this theta 1 is going to be the bearing of the line OA? Yes or no? Can we say this theta 1 is we have measured the angle from the north in the clockwise direction. Can we say the bearing of the line OA is going to be the theta 1? Yes or no? Similarly, if we want to measure the angle, if we want to define the bearing of the line OB, we will measure the angle from the north in the clockwise direction. Let's say this angle is going to be theta 2. Always the reference will be north and always the direction will be clockwise in the WCB system. Similarly, if we want to measure the bearing of the line OC, we will measure the angle from the north in the clockwise direction, and let's say this angle is going to be theta 3. This angle is going to be theta 3. Similarly, if we want to define the bearing of the line OD, we will measure the angle from the north in the clockwise direction, and this angle is going to be theta 4. So we can represent the bearing of the line OD as theta 4. We can represent the bearing of the line OD as theta 4. I hope there is no doubt to anyone. How we can measure the bearing of any line in the WCB system is clear to everyone. Always we will measure the angle from the north. Direction is going to be the clockwise. If I talk about the representation, to represent the bearing of any line, only angle will be sufficient. As you know the value of the angle, you can locate that line. Yes or no? So only angle will be sufficient to explain the position of any line in the WCB system. Yes or no? And if I talk about the range, so if we are representing the bearing of the line in WCB system, can I say the bearing will vary from 0 to 360 degree? The bearing will vary from 0 to 360 degree. What will be the range of the bearing in the WCB system? The bearing will vary from 0 to 360 degree. So these are the characteristics of your WCB system. Similarly, now let's talk about the RB or QB system. Now let's talk about the RB or QB system. So in the case of RB or QB system, what we will do? So let's take same example. So this was your east, west, north, south. This was the point O. This was the line A. So this is going to be the line B. This is going to be the line C. And this was the line D. This was the line OD. So in the case of RB or QB system, the first point from where we are going to measure this angle, the reference may be north and reference may be south. Same lines are there that we have considered earlier. Same lines we are considering to understand the RB or QB system also. So if I talk about the reference, so we can measure the angle from the north or we can measure the angle from the south. Both from both position we can measure the angle. So now the next point is in which direction we need to measure the angle. So when we will measure the angle from the north, when we should measure the angle from the south, who will tell you? So let's see the concept. For which line you want to define the bearing? Let's check that line is near from the north or near from the south. For which line we want to define the bearing, we will check that line is near from the north or the line is near from the south. Which will be near? If the north is near, we will measure the angle from the north. If the south is near, we will measure the angle from the south. So can I say, if there are two references, we can measure the angle from the north, we can measure the angle from the south. So can we say the direction may be clockwise, or the direction may be anti-clockwise. The direction may be clockwise or the direction may be anti-clockwise. Yes or no? Again there will be the confusion. So for example, if I want to represent the bearing of the line OA, OB, OC, OD in the RB or QB system, if I want to represent the bearing of the line OA, OB, OC, OD in the RB or QB system, let's talk about the line OA. So What will be the reference for measuring the bearing of the line OA, north or south? What will be the reference for defining the bearing of the line OA, north or south? So let's check. This line O is A, near from north or near from south? So that we can say it is near from north. That's why we are going to measure this angle. Let's say this angle is theta 1. Let's say this angle is theta 1. So, can I say to represent the bearing of any line in the RB or QB system, we also require to mention the direction? Because this theta 1 will not sufficient. That theta 1 you can also measure from the south. Yes or no? So, how I will know if this angle you have measured from the north or this angle you have measured from the south? So that's why we are saying in this system, we also need to mention the direction. So we are measuring the angle from the north. Angle is theta 1 towards the east. So this is going to be the bearing of the line OA. Similarly, if I talk about the line OB, we can measure the angle from the south. So let's say this angle is theta 2. So I will write this is going to be south theta 2 towards east. We need to also mention the direction. If I talk about the line OC, let's say this angle is going to be theta 3. So I will write south theta 3 west. If I want to define the angle of the line OD, bearing of the line OD, let's say this angle is theta 4. We will mention north theta 4 west. So can I say in the case of RB or QB system, for the representation, direction is also required. So north theta east, north theta west, south theta east or south theta west. We need to also mention the direction in the case of RB or QB system. Yes or no? In the case of RB or QB system. So, can you tell me what will be the range of the bearing of any line in the case of RB or QB system? What will be the range of bearing of any line if we are representing the bearing in RB or QB system? Yes, the range will vary from 0 to 90 degree. The range will vary from 0 to 90 degree. So I hope both these systems for representation of the bearing like WCB system and the RB and QB system is clear to everyone. If yes, please confirm in the chat box. If the discussion till now is clear to everyone, confirm in the chat box. And if there is any doubt related to the WCB or RB or QB system, you can ask your doubt. You can ask your doubt, you can ask your query. So these are the representation. So we have discussed about the WCB system in detail. We have discussed about the RB or QB system in detail. We have discussed about the RB and QB system in detail. So all the features that I have explained are mentioned here related to the whole circle bearing system and related to the quadrantal bearing system. What is the application? What is the application? What is the application? What is the application? So in the exam you will get the question related to the conversion. So they will provide you the reading in the WCB system and they can ask to convert all the bearings in RB or QB system or vice versa. Or vice versa. So let's take an example and I want you all should solve this example. So let's take an example. The bearing of the line OA is given as 55 degree. The bearing of the line OB is given as 130 degree. the bearing of the line OC is given as 220 degree and the bearing of the line OD is given as 340 degree, can I say all these readings, all these bearings that they have provided in the WCB system? All the given bearings are in WCB system because only angle is there for the representation of the bearing. Now you need to convert all these bearings in the RB or QB system. Now you need to convert all these bearings in the RB or QB system. Very easily we can convert. So let's say with the help of the diagram also, this line is OA, this angle is given as 55 degree. This line is OB, this angle they have provided as 130 degree. This line is OC, this angle they have provided as 220 degree, and this line is OD and this angle they have provided as 340 degree. Now if I want to define the same bearings in the RB or QB system, so what we can say, for line OA, the bearing is going to be, this is going to be your east, west, north and south. So north 55 degree east. For the line OB, we need to measure the angle from the south towards the east, and this remaining angle is going to be 50 degree. 180 minus 130. 180 minus 130. Similarly, if I talk about the line OD, OC, so this is going to be, this angle will be equal to 180, 40. So south 40 degree, west. For line OD, we require this remaining angle 360 minus 340. So north 20, west. I think there is no problem. So similarly, they can provide you the bearing in the RB or QB system. They can ask the bearing in the WCB system. So you will get these type of the conversion related problem in your exam. In general, both systems are correct. Both systems are correct for the representation of bearing. WCB system and RB and QB system, both are correct. But what do you think? Which system is easy? Or you can say, which system of the representation of bearing is less confusing? You are comfortable with which system? WCB system or RB or QB system? You are comfortable with which system? WCB system or RB or QB system? Obviously the answer is going to be WCB system. Because there is only one reference, there is only one direction, and to represent the bearing there is only angle is required. So it will be easy for us to understand in the case of WCB system as compared to the RB or QB system. There may be some little bit confusion, or there we can commit some silly mistake in the case of RB or QB system, because there are two references, there are two direction, we need to mention the direction also, so there are some chances of the error, but I think WCB is quite easy and simple. So in the upcoming lectures, whenever we will talk about the bearing, we will represent our bearing in the WCB system. No problem with that. If you want to represent the same bearing in the RB or QB system, you can easily convert. No problem with that. So this is not any rule. This is the general practice. In which system we are more comfortable, we will follow that system. Sir, but in the exam, sir, if they have provided the question and if they have provided the data in the RB or QB system, so what we will do? Very easily we can convert all those data in the WCB system. And we can solve the question in the WCB system itself. Let's say if they are asking the answer in the RB or QB system. So whatever final answer we are getting in the WCB system, can we easily convert that WCB reading into the RB or QB system? And then we can easily report our answer. So by following this practice, chances of error will be less, chances of mistake will be less. So whenever we will see any question related to the bearing, always we will solve the bearing, always we will solve that question in the WCB system. Final answer they are asking in the RB or QB, no problem with that. We can convert our answer into the RB or QB system very easily. So at that point of view, this conversion will also going to helpful for all of you. This is not any rule. If you are comfortable with RB or QB system, I don't have any problem. But I am mentioning those points from which you can avoid the silly mistakes in the exam. So I hope the discussion till now is clear to everyone. I hope the discussion till now is clear to everyone. So can we move further? Can we move further? Yes or no? So we know the true bearing. So the true bearing of a line is also called as azimuth. So that you should know about this term. The true bearing of the any line is also known as the azimuth. So if we are using the term true bearing, if we are using the term azimuth, both is having the same meaning, both is having the same significance. Azimuth is the bearing of true bearing of any line. That's it. Clear? So sometimes they can ask in the exam. So now we have also discussed about the magnetic bearing. So for the magnetic bearing, the reference will be, for the magnetic bearing, the reference will be, tell me in the chat box. The magnetic bearing, for the magnetic bearing, the reference will be, WCB is also called azimuth. Yes, you can say. Yes, you can say. If you are measuring the bearing in the WCB system, yes. So for that we required not magnetic north, we required magnetic meridian. We required reference as the magnetic meridian. Initially we have discussed all these points in detail. Initially we have discussed all these points in detail. Clear? For the true bearing, the angle is going to be the true meridian. For the true bearing, the angle is going to be the true meridian. Now we are moving towards the next important terminology in the compass surveying. And what is that terminology? The next terminology is magnetic declination. The next terminology is magnetic declination. Listen carefully. So first of all, how we can define this term magnetic declination? First of all, let's understand how we can define this term magnetic declination. So it is the horizontal angle. It is the horizontal angle between true meridian and magnetic meridian. It is the horizontal angle between the true meridian and magnetic meridian. Ria, please use the word meridian. Not true north, magnetic north. It is the angle between the true meridian and magnetic meridian. At any place, we can identify the magnetic meridian. At any place, we can locate the magnetic meridian with the help of the compass. No problem with that. And there will be no change in the position of the true meridian. If we consider the ideal shape, if we consider the ideal position of the earth, so at that time what poles we are getting, for that we are using the term true north and true south. And a line joining the true north and true south will be considered as the true meridian. So there will be no change in the position of the true meridian. But as this tilt angle will change, there may be change in the position of the magnetic meridian. There may be change in the position of the magnetic meridian, but the true meridian will fix, remain same. But the true meridian is going to remain same. I think there is no problem with this point. This point is clear to everyone. This point is clear to everyone, yes or no? So, how we can measure this angle, how we can define this angle? So, let's first understand. Let's say this is the position of the true meridian. So, this is going to be your east, west, true north and true south. So, you have two options. You have two cases. Let's say this is going to be the true meridian. Let's say this is going to be the true meridian. Listen carefully. Listen carefully. Our position of the magnetic meridian may be something like this. Our position of the magnetic meridian may be something like this. Or the position of the magnetic meridian may be something like this. So this green one is the magnetic meridian. This green one is going to be the magnetic meridian, and this white one is going to be the true meridian. As you can see, because there may be the change in the position of the magnetic meridian, true meridian will always remain same. There will be no change in the position of the true meridian. There will be the change in the case of the magnetic meridian. That we have understood. So how we are defining the magnetic declination? How we are defining the magnetic declination? So we have defined the magnetic declination as it is the horizontal angle between the true meridian and magnetic meridian at any particular place. It is the horizontal angle between the true meridian and magnetic meridian at any particular place. So can we define the magnetic declination here? Yes, we can define. So we can measure the horizontal angle between the true meridian and magnetic meridian. This theta is going to be the declination. Here this theta is going to be the declination. Is there any difference in these two cases? Yes. There is a difference. See carefully. This theta you are measuring, I think, in the clockwise direction. Depending upon the position of the magnetic meridian, you can see in the first diagram, we are measuring the theta in the clockwise direction. We are measuring our theta, we are measuring the declination in the clockwise direction, yes or no? We are measuring the declination in the clockwise direction, yes or no? So can I say, for this we can use the term clockwise declination? For this, can I say this is the clockwise declination? It is general practice. We are considering the clockwise direction as a positive direction. Yes or no? It is the general practice that we are considering the clockwise direction as the positive direction. So if you don't have any problem, can I also say this is going to be the positive declination? Yes or no? We are measuring this angle towards east. We are measuring this angle towards east. If you don't have any problem, can I use the term eastern declination? All have same meaning. All have same meaning. So agar if I am saying that there is a eastern declination, so with the help of this statement only, if I am using the term there is a eastern declination, so with the help of this statement only, you can locate, you can understand the position of the magnetic meridian. Yes or no? Because the position of true meridian will not change. Because the position of the true meridian will remain same. I hope this point is clear to everyone. Yes or no? Similarly, if we talk about the second diagram, so can I say this angle we are measuring in the anti-clockwise direction? This angle we are measuring in the anti-clockwise direction. General practice, we are considering the anti-clockwise direction as a negative direction. Or this angle we are measuring towards the west. So can I say, can I also use the term western declination? Yes or no? So how we are defining the magnetic declination? It is the horizontal angle between the true meridian and magnetic meridian. There are two types of the declination. One is the clockwise declination. or positive declination or eastern declination, and another is anti-clockwise declination or negative declination or western declination. So what is the declination and what are the different types of the declination? This point is clear to everyone, yes or no? This point is clear to everyone, yes or no? So if anyone having any doubt, whatever we have discussed till now in the case of compass surveying, at any point if you are having any doubt, any query, you can ask your doubt, you can ask your query. So sir, from this topic, from this declination, which type of the question we can get in the exam? This is my query. Which type of the question that we can get in the exam? So should we solve some question? Should we solve some question based on the declination? Are you ready for the questions? Okay. So let's solve. We will solve two questions. So we have discussed about the magnetic declination. Now we will see the question. Chalo first solve some question. So this is your question number 1 and this is your question number 2. So in the question they have provided, at any place declination was 7 degree east. At any place the declination was 7 degree east. The magnetic bearing of any line is measured as 50 degree. So what will be the true bearing of that same line? This is your question number 1. At any place the declination is 7 degree west. The true bearing of the line was 50 degree. What will be the magnetic bearing of that line? What will be the magnetic bearing of that line? Can you solve these two questions? Can you solve these two questions? Can you solve these two questions? So Riya is saying for the first answer is going to be 57 degree. Yes, Riya. Are you facing any difficulty in the compass surveying? So in the last lecture you were telling, the compass surveying is very difficult topic. So now I want to know whatever topics we have covered till now in the compass surveying. Do you have any problem at any concept of the compass surveying till now? Yes, everyone, tell me the answer for both the question number 1 and question number 2. Tell me the answer for both the question number 1 and question number 2. So just try to understand the concept. There is no need to use any formula or anything. We can go with the basic concepts. We can solve these questions very easily, and these type of the question you are getting frequently in your exams. In GATE, in ESE or in state AE, in all the exam you are getting the question like this from this particular topic, that is the declination. So just do one thing. We know what will be the situation. The position of the true meridian will not change. Just go with the basic. The position of the true meridian will not change. Declination is given as east. That means this should be the position of the magnetic meridian, and this angle they have provided as 7 degree. यही मतलब हुआ? Yes or no? This is the true meridian. This is the magnetic meridian. The angle between the true meridian and magnetic meridian is considered as the declination. Here the declination is given as 7 degree east. That's why this should be the position of the magnetic meridian. There is one line for which they have provided the magnetic bearing, and that is 50 degree. As we know, magnetic bearing we will measure from the magnetic meridian. Magnetic bearing we will measure from the magnetic meridian. So what will be the true bearing? What will be the true bearing of the same line? So they have asked about this angle theta. If we want to define the true bearing of any line, we need to measure the angle from the true meridian. We need to measure the angle from the true meridian. Yes or no? That is the very simple thing. So this theta we can write, this is going to be 7 degree plus 50 degree, and that answer is going to be 57 degree. The answer is going to be 57 degree. Let's see the case 2. Again, the position of the true meridian will not change. The position of the true meridian will not change. In the second case, they have provided the declination as 7 degree west. So this is going to be the position of the magnetic meridian. Now they have provided the declination as 7 degree west. Again for a line, now that they have provided you the true bearing. So true bearing is given as 50 degree. That means this angle is given as 50 degree. This angle is given as 50 degree. True bearing is given as 50 degree. So what will be the magnetic bearing? What will be the magnetic bearing? What will be the magnetic bearing? In this question they have asked about the true bearing. Yes or no? So simply we have calculated. 43 आ रहा है. 43. Magnetic bearing we have to measure from the magnetic meridian. Magnetic bearing we have to measure from the magnetic meridian. Dear, do not get confused. Magnetic bearing we have to measure from the magnetic meridian. Magnetic bearing we have to measure from the magnetic meridian. They have asked about this angle. So this is going to be 7 degree plus 50 degree. That will be equal to 57 degree. So do not get confused. Do not get confused. 43 कैसे आ रहा था? How we were getting the 43? True bearing we will measure from the true meridian. Magnetic bearing we will measure from the magnetic meridian. In this question they have provided you the value of the magnetic bearing. In this question they have provided you the value of the true bearing. Have you got the concept? So we have not applied any formula. We have not applied any formula. Simply we have gone through the basics. We know what is declination. We know declination is the horizontal angle between the true meridian and magnetic meridian. We know what is the eastern declination, what is the western declination. We know about the true bearing. We know about the magnetic bearing. For measuring the true bearing, we will take the reference as true meridian. For measuring the magnetic bearing, we will take the reference as the magnetic meridian. That's it. I little confused. What is your confusion? What is your confusion? What is your confusion? What is your confusion? But if you have any doubt, any query, you can ask your doubt. So we have solved all these questions from the very basic concept. Again, I am repeating. If you want to solve these type of the question, you should know all the basic term. Like, what do you mean by the magnetic declination? What do you mean by the magnetic declination? The magnetic declination is the horizontal angle between the true meridian and magnetic meridian. The position of the true meridian will not change. The position of the magnetic meridian can vary. The position of the magnetic meridian can vary. We have two types of the declination, eastern declination and western declination. We know the concept. If we want to define the true bearing of any line, we will measure the angle from the true meridian. If we want to define the magnetic bearing of any line, in that case we will define the angle, we will measure the angle from the magnetic meridian. That's it. So whatever data they have provided, based on that data, we can solve this question like this. But read the question carefully. Read the question carefully. In the question number 2, some of you have committed mistake. Yes, some of you have committed silly mistake. They have provided you the true bearing. You are considering that value as the magnetic bearing. Why? So from question point of view, read the question carefully, then solve the question and mark your answer. Otherwise, you will commit the silly mistake. Instead of plus mark, you will get the negative mark in the exam. Instead of plus mark, you will get the negative mark in the exam. Now I think the discussion about the declination is clear to everyone. So as we have discussed, there may be the variation in the declination if the position of the magnetic meridian can change. If the position of the magnetic meridian can change, so obviously there will be the change in the declination also. If the position of the magnetic meridian will change, the angle between the true meridian and the magnetic meridian will also change. So what are the different types of the variation in the declination that we will see? So some variation you will see based on the daily basis. Some variation you will see based on the daily basis. So that type of variation we are saying as diurnal variation. Diurnal variation is the variation in the declination that occurs on the daily basis. So on the daily basis, what will be the change in the position of the magnetic meridian? On that basis, what is the change in the magnetic declination at that place? That will be considered as the... Okay, next I will consider it and implement each and everything whatever you told us. Definitely, beta. Definitely. So the variation that we are observing at any place on the daily basis in the declination will be considered as the diurnal variation. Some variation you will observe based on the yearly basis. So for that we will use the term annual variation. So in a year, if there is any change in the declination at that place, that variation we will consider, that change we will consider as the annual variation. Variation means, for example, this is the true meridian and this is the magnetic meridian. This is the magnetic meridian. Now this angle is 7 degree. तो एट प्रेजेंट यहां पर डिक्लिनेशन क्या है? 7 डिग्री ईस्ट. यस और नो? एट प्रेजेंट द डिक्लिनेशन इज 7 डिग्री ईस्ट. लेट्स से आफ्टर 1 year फॉर द सेम प्लेस, आफ्टर 1 year, this is the position of the magnetic true meridian and this is the position of the magnetic meridian. Now this angle is 5 degree. So after 1 year, you can say the magnetic declination is going to be 5 degree east. There is the change in the declination. There is the change in the declination, and that change you are observing on yearly basis. So these variation we can consider as the annual variation. These variation we can consider as the annual variation. Now I think the point is clear to everyone. Now I think the point is clear to everyone, yes or no? Any doubt? Some variation you will see over a long period of time, like for example 100 years period, 150 years time period. These types of the variation termed as the secular variation. These type of the variation in the declination are termed as the secular variation. And sometimes you will see the variation having without any pattern, no pattern is there, no pattern, sudden change, accidental change, these type of the variation you are terming as the irregular variation. Irregular variations, whenever there will be no pattern, there will be sudden change. So these type of the variation you can consider as the irregular variation. So there are four types of the variation in the magnetic declination. There are four types of that variation in the case of magnetic declination. The variation that we are observing on the daily basis, we are knowing those variation as the diurnal variation. The variation that we are observing on the yearly basis, we are using the term annual variation. Over a long period of time, that variation we are observing, like in 100 year or in 150 years, these variations we are terming as the secular variation. Without any pattern, if there is a sudden change, if there is a sudden variation, that variation is considered as the irregular variation. That variation is considered as the irregular variation. Any doubt to anyone? Any doubt to anyone at any point? You can ask your doubt, you can ask your query. If anyone having any doubt, any query at any point, you can ask your doubt, you can ask your query. All the points are clear till now? Very good. All the points are clear till now. A simple observation is there that you need to remember. A simple observation is there that diurnal variation is more in the case of summer. If we compare summer and winter, if we compare summer and winter, to at any place it has been observed that the daily basis variation, diurnal variation is going to be more as compared more in the case of summer as compared to the winter. So this observation you should also know. On the variation that occurs on the daily basis will be more in the case of summer as compared to the winter. So directly they are asking this observation in your exam. So sometimes they can ask, so that you should know. Now let's understand the next topic, and then we have discussed about the type of declination. Yes or no? You can skip this term or the formulas. There is no formula as such. We will go from the basic. So eastern declination, clockwise declination, positive declination. Similarly, western declination, anti-clockwise declination or negative declination. All these points we have covered. We have also solved a question based on it. We have also solved a question based on it. So in this way we have completed our discussion for the declination. Now let's move to the last term. Now let's move to the last term. And the last term is angle of dip or angle of depression. Angle of dip or angle of depression. So let's talk about this term. So what do you mean by the angle of dip? What do you mean by the angle of dip or angle of depression? Till now, we have majorly talked about the horizontal angle. Bearing was the horizontal angle. True bearing horizontal angle. Magnetic bearing horizontal angle. Magnetic declination horizontal angle. For the very first time in the compass surveying. For the very first time in the compass surveying, we are going to talk about the vertical angle. And that is the angle of dip or angle of depression. Listen carefully. Listen carefully. So it is the vertical angle. It is the vertical angle. Obviously, if this is the vertical angle, so how we are measuring this vertical angle? That we should also know. So it is the vertical angle between. It is the vertical angle between Earth surface. It is the vertical angle between Earth surface and magnetic flux line. It is the vertical angle in between the Earth surface and magnetic flux line. Let's try to understand. Let's try to visualize this angle. Let's try to visualize this angle. Consider this as a earth. Consider this as a earth. So this is going to be the north pole. This is going to be the south pole, yes or no? This cap portion is going to be the north pole and this is going to be the south pole, yes or no? Consider this earth like this, yes or no? So this is going to be the north pole and this is going to be the south pole. ठीक है? We know about the magnetic flux line. So in your 11th or 12th in basic physics, you must have used the magnetic needle to locate the magnetic lines. Do you remember? In your basic physics, you have used magnetic needle to indicate the magnetic lines. So that will all the lines will originate from the north and terminate to the south. Do you remember? Do you remember, yes or no? So these are the magnetic lines, or you can say these are the magnetic flux lines. North to south. It will originate from the north and terminate to the south. Do you remember this concept? And that you have indicated, that you must have located with the help of the magnetic needle. So these are the magnetic flux line. Can I visualize the magnetic flux line are originating from the north and terminating toward the south, something like this, from the north to the south like this, from the north to the south pole like this, yes or no? Are you able to visualize? Are you able to visualize? Are you able to visualize how these flux line are originating and terminating? I hope you can visualize. Now read this statement. Now read this statement. So this statement says angle of dip or angle of depression is the vertical angle between the earth surface and the magnetic flux line. So let's say this is the north pole. So at north pole, this is going to be the earth surface, yes or no? Or as we know, at the poles, this region is flat. At the pole, at the north and south pole, this region is flat. So can I represent this line as a earth surface? Hey bhai, ruk jao. Can I represent this line as a earth surface, yes or no? Can we represent the earth surface like this, yes or no? Tell me in the chat box. At north pole, this should be the earth surface, yes or no? Everyone please confirm. In this way, can we represent the earth surface? Okay. Just we have talked about the magnetic flux line. Just we have talked about the magnetic flux line and you just have mentioned it will originate from the north and it will terminate to the south. Something like this. I hope you can see this wire. I hope you can see this wire. Consider this as the magnetic flux line. It is originating from the north and terminating to the south, something like this. These are the magnetic flux line. So if I want to measure the angle of dip or angle of depression, so can I say at the pole the situation will be something like this. At the pole, this is the earth surface, this is the magnetic flux line. Can we say this angle is going to be the vertical angle between the earth surface and magnetic flux line? Yes or no? Yes or no? So we can draw the tangent somewhere here. So this is going to be the magnetic flux line. This is going to be the earth surface. Can we measure this angle? This angle is going to be the 90 degree at poles. Both lines are not in the same plane. This is your earth surface. This is your magnetic flux line. This angle we are defining as the angle of dip or angle of depression. That's why we are using the term, it is the vertical angle between the earth surface and magnetic flux line. It is the vertical angle between the earth surface and the magnetic flux line. Same story will be there in the case of South Pole also. Same story will be there in the case of South Pole also, yes or no? Tell me in the chat box. Same story will be there in the South Pole also. So can I say, if I talk about poles, at poles, this angle of dip is going to be 90 degree. At North Pole and South Pole, this angle of dip or angle of depression is going to be 90 degree. If I talk about the equator, can you tell me what will be this angle of dip or angle of depression at equator? Do remember, it is the vertical angle between the magnetic flux line and earth surface. So at equator, this is going to be the earth surface and this is going to be the magnetic flux line. They are parallel. There will be no vertical angle. Yes or no? So at equator, you can say this is the position of the earth surface and this is the magnetic flux line. How we can define the vertical angle? Can we say at equator, this angle of dip or angle of depression is going to be 0 degree? Can I say at equator, this angle of dip or angle of depression is going to be 0 degree? If you can visualize, then only you can confirm in the chat box. If you can visualize all these points, then only you can confirm in the chat box. So if I talk about the poles, the angle of dip is going to be 90 degree. If I talk about the equator, there will be no vertical angle between these two terms, earth surface and magnetic flux line. Because these both earth surface and the flux line at equator are going to parallel to each other. Got it? Very good. At any other position apart from the pole and apart from the equator, can I say at any other position? At any other position, this angle will vary from 0 to 90 degree. This angle of dip or angle of depression will vary from 0 to 90 degree. Yes or no? This angle of dip or angle of depression will vary from 0 to 90 degree except from the equator and poles. Any doubt to anyone? Any query to anyone related to the angle of dip or angle of depression? Yes, at poles, both. Similarly, if I talk about the south pole, this is going to be the earth surface and this will be the flux line. The angle is going to be same, 90 degree. The angle is going to same, that will be 90 degree. So this was the discussion related to the angle of dip or angle of depression. Related to the angle of dip or angle of depression. Angle of dip 0 degree at equator, 90 degree at poles, and it will vary from 0 to 90 degree at any other position. So in the compass surveying, what we have discussed till now. So what was the objective for the today's class? The objective was to understand the basic concept of the compass surveying, in which we have discussed the principle of the compass surveying. We have discussed about the measurement of the angles, or you can say the measurement of the bearing. And to define the bearing, we have defined the meridian. With the help of the true meridian, we can measure the true bearing. With the help of the magnetic meridian, we can measure the magnetic bearing. Then we have discussed how we can designate or represent the bearing, for which we have discussed about the WCB system, that is whole circle bearing system, and RB or QB system. We have discussed about the WCB system and RB and QB system. Then we have discussed about the magnetic declination, and we have also discussed about the angle of dip. Yes, all these terms are related to the magnetic north and magnetic south. Just ideally we have defined the true north and true south. So the actual north and south are available. We are considering those north and south. We are considering magnetic north and magnetic south for all the analysis. So I think I have explained all these terms enough so that you should have clear understanding about all these concepts. So everyone please confirm in the chat box the discussion is clear to everyone. So let's take one more point. So we have discussed about the two types of the compass. We have discussed about the two types of the compass. One was the prismatic compass, one was the surveyor compass. So as of now, we have discussed about the WCB system and RB or QB system. So you can just mention here the prismatic compass works on the WCB system, because the readings you will get in with the help of this compass, that will vary from 0 to 360 degree. Whenever we will measure the angle, whenever we will measure the bearing from the prismatic compass, the bearings will vary from 0 to 360 degree. So can I say it works based on the WCB system, and our surveyor compass is based on the RB or QB system, because the maximum angle that you can find, the range of the bearing with the help of this surveyor compass is going to be 0 to 90 degree. Here the range will be equal to 360 degree. So we have discussed this range you will get in the case of WCB system. This range you will get in the case of RB or QB system. This range you will get in the case of RB or QB system. So I hope now the entire discussion is clear to everyone. So we have discussed till the angle of dip or angle of depression. So in the today's class, we have completed all the important and basic terminology related to the compass survey. Now what next? So now how we can measure the bearings? How we can measure the bearings in the field with the help of the compass? How we can measure the bearings in practical, from practical point of view? How we can measure the magnetic bearing of the line with the help of the magnetic compass? In that we will cover the ranging and sighting, don't worry. So now we will see the working of the prismatic compass. Now we will see some basic working of the prismatic compass, and then we will perform some field measurements. And then we will discuss what are the various sources of the error in the compass survey. What are the various sources of the error in the compass survey, and how we can identify those errors, how we can apply the suitable corrections for those errors. So these are the next part of the discussion in the compass survey. So anyway, whatever we have discussed till now, I hope the entire discussion is clear to everyone. So everyone please confirm in the chat box, whatever we have discussed in the compass surveying till now is absolutely clear to everyone, yes or no? So from tomorrow you will get the DPP. Because all the basic part, there are no as such more question related to these topics. All these topics are the very basic, and all the discussion we are taking in the class itself. So hardly you will find 2 or 3 questions in your PYQs from these topics. So depending upon the weightage and depending upon the frequency of the question in your exam, we will get the DPP. We will provide you the DPP. Don't worry. All the discussion is clear to everyone? Very good. So, this was all about for this class. मिलते हैं tomorrow. See you tomorrow for the further discussion. And I hope you all are revising the concepts and you are all are practicing the GATE and ESE PYQ. So whatever topics we are completing one by one, do practice the PYQs minimum, at least GATE and ESE PYQ. So that why after covering the concept, you should have clear understanding which type of the question they are asking in the exam. So this was all about for this class. See you tomorrow. Thank you everyone. Keep learning. Good night.